All right, so if we are given a graph, we need to pull the information out of it that we need in order to make the equation of the graph. So we're going to pull some key points and some asymptotic behavior. So one of the first things I notice is that I've got an x-intercept at positive 3. Okay, so my x-intercept is going to be in the numerator. So x-intercept refers to numerator. To numerator. Okay, your y-intercept is going to be what we find last. It's going to be your a. Okay, your vertical asymptotes are going to refer to your denominator, because that's where we're going to find out where it doesn't exist. Refers to denominator. And now we've got horizontal asymptotes. So my horizontal asymptote, refers to the degree and the lead coefficient. Okay, refers to the degrees and the lead coefficient. So, looking at this mess right here, first thing I notice is that I have an x-intercept at positive 3. So if my x-intercept is positive 3, that means my factor for it would be x minus 3. So that's my numerator so far. Next thing I want to notice is vertical asymptotes, so I can start building my denominator. So I've got a vertical asymptote at x equals negative 3, which if my asymptote is at x equals negative 3, that means the factor will be x plus 3. These don't reduce. If my vertical asymptote is at x equals 4, that means his factor is at x minus 4. Okay, so I've done some of the work that needs to be done, and now I have to infer some information. So the last thing that I can do dead on is state what my what my y-intercept is. So my y-intercept is at 0, 1. So that's going to be the x and the y that I use to find the a value. The last thing I want to do is I want to find what my my horizontal asymptote is, which is going to be in the form y equals. So I have a horizontal asymptote at y equals 0. If my horizontal asymptote is y equals 0, then what I have is a small degree over a big degree. So looking at the way this stands, I've got an x to the first over an x squared. Okay, an x to the first, because I've got a single x up here, over an x squared, because x times x is x squared. So that's a small over a big. Okay, so right now I'm good. So at this point, I'm going to put a coefficient of a in there, and I'm going to see what I can create. So what did I do first? I grabbed my x-intercept, which was my numerator. I grabbed my vertical asymptotes, which were my denominator. I noted what my y-intercept was, because that's going to help me with the coefficient. And then the horizontal asymptote will talk to me about the degrees and the lead coefficient. So I already took care of this with a small over a big. So now I'm done with that information, so let's just plop this in here. So I've got 1 equals a times 0 minus 3 over 0 plus 3 times 0 minus 4. Hang on. Wait. All right, found another one. All right, 0 minus, damn it. All right, 0 plus 3, 0 minus 4. So, can't put an arrow there because I got an equal sign. All right, so 1 equals 0 minus 3 is negative 3. And then my denominator is 3 times negative 4. So I get 1 equals a negative 3a over a negative 12. Okay, so my negatives reduce. So this becomes a plus positive. I'm going to multiply both sides by 12. So 12 equals 3a. Divide both sides by 3. So 4 is the value that I get for a. So coming back up here, here's my handy dandy toy. This I'm going to find out is not A anymore. This is 4. So this is the final answer for the equation of that rational function. All right, so let's try another one. We have, I'm going to do X-intercepts first, and then I'm going to look at vertical asymptotes, and then I'm going to look at horizontal asymptotes, and then I'm going to finish up with a Y-intercept. I didn't quite get it in that same order. So what is my X-intercept? I've got an X-intercept at positive 2. So if my X-intercept is positive 2, my factor is X minus 2. So X-intercepts direct me towards the numerator. So the numerator's done. The vertical asymptotes will direct me towards the denominator. So I've got a vertical asymptote at X equals negative 3, and I got a vertical asymptote at X equals positive 3. So if my asymptote is at negative 3, the factor is X plus 3. If the asymptote is at positive 3, the factor is at X minus 3. All right, so what else do we have? I've got a horizontal asymptote at Y equals 0. So if my horizontal asymptote is Y equals 0, that means I've got a small degree over a bigger degree. So I've got an X to the first over an X squared. So far I'm good. Okay, I don't need to make any adjustments for this. The last thing I want to look at is what is my Y-intercept. So my Y-intercept is at negative 2. So I've got 0, negative 2. And I'm going to fill this thing in by saying Y equals A times X minus 2 over X plus 3, X minus 3. So I know that I should get a negative 2 equals A times 0 minus 2, 0 plus 3, 0 minus 3. So negative 2 equals negative 2 times A, because 0 minus 2 is negative 2. Negative 2 times A is negative 2A. 0 plus 3 is 3. 0 minus 3 is negative 3. So 3 times negative 3 is negative 9. And now my negatives reduce again, so I'm going to make those both positive. At this point, I'm going to multiply both sides by 9. You're multiplying, so don't subtract that. So that gives me a negative 18 equals 2A. And then I'm going to divide both sides by 2. So I get negative 9 is A. So coming back up to this function, I can now erase my A because I know that that's actually a negative 9. That is actually a negative 9. All right, so let's do another one. We have, oh, this is going to be fun. All right, we have an intercept at 1. So if my intercept is at 1, but look at the behavior. It comes up and it bounces back down. So that tells me that that has multiplicity of 2. Okay, so what are we going to do first? We have, after I find some clean paper, X-intercepts first. So my X-intercept is at positive 1, which means my factor is going to be X minus 1, but it behaves like a kind of a weird parabola right there. So since I'm looking at just the little parabola right there, my numerator is actually going to be X minus 1, but it appears twice. Okay? Then what do I have? I need to look at my vertical asymptote. So I've got a vertical asymptote at negative 3 and a vertical asymptote at positive 2. So if my asymptote is at X equals negative 3, its factor will be X minus 3. If my asymptote is at positive 2, its factor will be X minus 2. And now we have somewhat of an interesting development here. So because this has multiplicity of 2, okay, I've got a horizontal asymptote at Y equals 0. So that tells me this needs to be a small over a big, okay? But what I have on top is a degree of 2. What I've got on bottom is a degree of 2. So what I know is that one of these two things needs to be squared, okay? One of those two things needs to be squared. I got to figure out which one it is, okay? So I'm going to trying to figure out which direction I want you to go on this. If you look at this and compare it to your toolkit functions, okay, the behavior of this will be compared to 1 over x squared. So notice that it's going the same direction on either side of the asymptote. So it's a 1 over x to the even, okay? Notice that on this one, the behavior on either side of the asymptote is shooting off in opposite directions. So this would be like a 1 over x to the odd, okay? So if I look at this as, oops, sorry, made you dizzy. As I look at this as a 1 over, so I'm just excluding this for just a second. I would have a 1 over, my x minus 3 needs to be raised to an odd power because it relates to the toolkit function of 1 over x to the odd. Okay, this one needs to be x to the even because its behavior around the asymptote relates to and 1 over x squared or a 1 over x to the even. So that's just kind of a little detail that got shoved in there. But now look what happens when we do that. Now I've got an x squared over an x to the third. So now I've matched my small over big. Okay, so I knew I had to match my small over big. I knew I was going to have to increase one of these exponents, and I wasn't sure which one it was till I looked at the behavior around the asymptote. So I've looked at the behavior around the asymptote, and now we're going to go in and find out what our a value is. So I've got a y-intercept at 0, negative 1/2. So my y-intercept is at 0, negative 1/2. So if I've got y equals a, now I can plop all this stuff in here. So my y is going to be a negative 1/2 equals a times 0 minus 2 squared over 0 plus 3 times 0 minus 2 squared. Hold on, I just hyperventilated because I noticed that I wrote this wrong. This whole problem is just a mess. Okay, so that was supposed to be a 1 and that was supposed to be a 1. So this was an x minus 1 squared because y, our exponent is, our intercept is at 1. And I just was not paying attention. I am so sorry. So, because I was thinking, oh no, these things reduce. But they don't reduce because they're not supposed to reduce. All right, so I had to stop and regroup. What we have here is my mistake. I was supposed to write x minus 1 and I accidentally wrote x minus 2. Okay, my intercept was at positive 1, which means its factor is at x minus 1. And then it has behavior like a quadratic, so I need to make it squared like a quadratic. All right, let's get through this thing. So I've got a negative 1 over 2 equals a times negative 1 squared over 3 times negative 2 squared. So negative 1 over 2 equals negative 1 times negative 1 is 1 times a is a over 3 times negative 2 times negative 2 is 4. So I get a 12. Okay, so 3 times positive 4 is 12. Now I'm going to cross multiply. So I get a negative 12 is 2a, which is going to make this value a negative 6. So my value for a, come back up here, is now negative 6. So he is negative 6. All right, so final example with graphs is I've got an x-intercept, I've got 2 vertical asymptotes, I've got a horizontal asymptote, and I've got a y-intercept. So I'm going to start looking at all these things. So let's do the x-intercepts first. So since I've got an x-intercept at positive 2, that means his factor will be x minus 2. And I need to look at his behavior. So his behavior is he comes down and bounces off, which means he looks like a little parabola right there, so he's going to be squared. Okay? Now let's look at our vertical asymptotes. So I've got a vertical asymptote at negative 2, and I got a vertical asymptote at 4. Watch your scale. So this is negative 2, and this is 4. So if my vertical asymptote is at x equals negative 2, my factor will be x plus 2. If my vertical asymptote is at x equals 4, then my factor will be x minus 4. Okay, so the last things I got to deal with are my horizontal asymptote and my y-intercept. My y-intercept is 0, 1/2. So I'll handle that in a second, but I've got to make sure that my horizontal asymptote, well, my horizontal asymptote is y equals 0, which screams to me that I've got a small over a big again. And the way that this is written is I've got a degree of 2 over a degree of 2, because x times x is x squared. So I've got a degree of 2 over degree of 2, which means one of these two things needs to be squared. So I'm going to look at the behavior on either side of the asymptote to determine which one needs to be squared. So if I look at the behavior around my x equals -2, which is my factor of x plus 2, it's shooting off in opposite directions, which tells me it's like a 1 over x to the odd. Okay? If I look at my behavior on this one, on either side of x equals 4, which is the factor x minus 4, they're going off in the same direction, which tells me that has the behavior of something being squared. It looks like a 1 over x squared. So this should be my squared term. Okay? So this is now an x squared over an x to the third. So I can come in and say I've got a 1/2 equals a times 0 minus 2 squared over 0 plus 2, 0 minus 4 squared. So I've got a 1 over 2 equals a times -2 times -2 is 4. And then I've got a 2 times a -4 times -4 is 16. So 2 times 16 is 32. And I'm just going to cross both sides. So I've got a 32 equals an 8a, which means a is equal to 4. So I'm going to X you out, be gone with you. And you are now going to be a 4. So that is the equation of what I just gave you.